Welcome back. This is section 11.6. We're going to talk about surface areas of pyramids and cones. The first thing I want to recognize is the pieces of a pyramid. So the vertex of a pyramid is the point in which the lateral faces share a common vertex. A regular pyramid has a regular polygon for a base, and the segment joining the vertex in the center of the base is perpendiculars. The slant height of a regular pyramid is the height of that lateral face. So we're going to see that here in just a moment in the picture. So come down here, and I got this lovely picture. For a regular pyramid, the base perimeter P, slant height L, and base area B, the lateral area L and the surface area S are as follows. So I have lateral area is 1/2 the perimeter of the base times the slant height. And here in the picture you'll see my slant height is going to be the height of this lovely lateral face. And in a regular pyramid, so that means I have a regular base, it'll help me find that slant height if I don't have it. But B does stand for the area of base, and that's whatever shape that base is. I do have some information here I'm going to leave on the screen, and you can pause here if you'd like to write it down. But this is just information for finding a rectangular pyramid, because we do have a couple of those, especially later in your review and just in general. Rectangular pyramids are not regular pyramids, so I cannot use the equation I'm given for my other pyramids. So essentially what I have to do is find the area of each triangular lateral face. The great thing about a rectangular pyramid is that I have 2 pairs of congruent lateral faces, so I can find 2 of my 4 and then just multiply that by 2, or each of them by 2, and that'll give me the area of my lateral faces. Then I need to find the area of the base, that lovely rectangle, and then finally I can add all areas together. There's really no other way to do anything other than this way for rectangular pyramids. Just like if we have any other kind of irregular shape, we will have to use this specific formula. And remember, regular polygons are going to be polygons whose all sides are congruent. So coming down here, let's go ahead. We're going to find the lateral area and surface area of this lovely pyramid here. Whew, we should have all of our lovely information. So let's go ahead and start with our perimeter to equal number of sides times the side length. The number of sides in my base, if you look over at your picture, is 6. The side length we found is 10. So it's the number of sides, 1, 2, 3, 4, 5, and 6. I have one side length of 10. So I have a regular hexagon here. If I multiply these, I get a perimeter of 60. And then I have my slant height, and it actually gives me that slant height of 14. So I'm going to come over here and say my lateral area equals 1/2 the perimeter times the slant height. 1/2 of 60 times the slant height of 14. And if I plug this into my calculator, I get my lateral area equaling 420 feet squared. Now, moving over to my surface area, I'm going to kind of do a little squiggle here just to keep my stuff separate. I can use that perimeter again that we found, that was 60. And then I need my apothem, which I'm actually given here. If you look at your apothem, it's right here, and that's 5 square roots of 3. So coming back over, I have 5 square roots of 3. And then I can go ahead and use my lovely formula. So I have the surface area to equal the base, or the area of the base plus that lateral area. Now my base formula, since I have a regular polygon, I have to use 1/2 apothem times perimeter. Notice how I do have that 1/2 in there because I only have one base. The only time I don't need that 1/2 is when I have two bases. So I have 1/2 here, apothem times perimeter, plus that lateral area that I had just found, and this is going to give me my surface area. So if I come over here and go ahead and just plug some stuff in, I have 1/2 times 5 square roots of 3 times 60. And then I simplify this a little bit. I can go ahead and combine these terms. So I have my base area to equal 150 square roots of 3. I can take this and plug this in up here. And then we're just going to go ahead and add that lateral area of 420. And then I'm just going to plug this into my calculator to get my surface area to equal just about 679.8 feet squared. There we go. And that's my final answer. So I have my lovely lateral area over here. I have my surface area there. And there we go. Okay, moving on. We're going to talk about cones now. So the segment joining the vertex and the center of the base is perpendicular when I have a right cone. So that gives me this lovely bit here. So if I look at this, I have a right cone because I create almost like a right triangle here. And then just like before, I do have a slant height that I have to be cautious of, and I actually have to use. The height that goes from the vertex to the center of my cone is the actual height of the cone, not the slant height. And in my surface area formula, I need that height. Now we're going to talk about when we do volume, you actually need the height of your cone, not the slant height. So keep that in mind. But voila. So I have this lovely formula. My lateral area is going to equal pi times the radius times the slant height. It's essentially the same thing as what I did before, where 1/2 the perimeter times the slant height. But the perimeter of a circle is the circumference formula. So I have 2 pi r, and I can go ahead and cancel out 1/2 and 2 to just get pi r slant height. That's what this lovely bit right here is kind of showing you, how I simplified that formula a little bit. Now, since I only have one circular base, I just do pi r squared. So just like the cylinder, this one is a little bit simpler because we do have one set formula. So let's focus on the lateral area first. And the lateral area, like I said, was pi r slant height. We have the radius of 6, but we don't have our slant height yet. So I'm going to come down here, and I'm going to go ahead and solve for the slant height using the Pythagorean theorem. Since I have this lovely right triangle kind of created here, I can go ahead and use the Pythagorean theorem to find that slant height. So I have 6 squared plus 8 squared equals slant height squared. This gives me 36 plus 64 to equal the slant height squared, which is 100 equals the slant height squared. And I can go ahead and take the square root of that, and I'll get 10 as my slant height. So, look up here, I have the slant height of 10. So I plug this in, pi times 6 times 10. This ends up getting me 60 pi meters squared. And I'm going to leave it there for now, because then I'm going to plug it into my formula down here for my surface area, which is going to be the area of the base, or pi r squared, plus that lateral area. So I have pi times 6 squared plus the lateral area of 60 pi This ends up getting me 36 pi plus 60 pi, which gives me an area, gives me a surface area of 96 pi, and I have meters squared again. If I round this to one decimal place, I have 301.6 meters squared, and that is my final answer. Okay, like I said, this is your cones and your pyramids. We like to group those together since they both have one base. Come back into the next video to learn about spheres.